The PigStun project aims to produce technical advice for slaughterhouses who want to move away from stunning pigs using high concentrations of carbon dioxide. In the slaughterhouse, different stunning methods are used to ensure that pigs are unconscious before killing. Stunning induces temporary loss of consciousness, after which the animals are killed by sticking before they recover consciousness. In EU pig slaughterhouses, two stunning methods are commonly applied: carbon dioxide stunning at high concentrations and electrical stunning. More than half of all European pigs that are slaughtered for human consumption are stunned with high-concentration carbon dioxide gas before being killed. However, exposure to high concentration of carbon dioxide during stunning raises concern because it's aversive to the animals, causing painful hyperventilation and irritation of the mucous membranes. Carbon dioxide stunning is efficient and causes less pre-stunning stress because the pigs are handheld in small groups. Electrical stunning results in immediate unconsciousness of the animal. But prior to stunning, the animals need to be lined up in a row. To keep the animals moving whilst going from a group to a single line often involves stress and painful stimuli such as electric prods. The general objective of the PigStun project is to encourage EU pig slaughterhouses using high carbon dioxide concentration for stunning pigs to convert to more animal welfare-friendly systems. A first alternative focuses on changes that can be made to optimize the current systems with high carbon dioxide concentration. This will be referred to as Optimized Control Atmosphere Stunning Process. Alternatives 2 and 3 involve inert gases, argon and helium in the stunning phase. These gases do not cause aversive reactions from the animals. The fourth alternative describes an improved electrical stunning system, primarily targeting the pre-stunning handling phase. The optimized CAS process is a carbon dioxide stunning method under development. It aims to minimize stress levels of pigs during the pre-stun handling by handling pigs in groups in an automated walkway, which includes guiding plates to gently move pigs forward. Reduction of pre-stunning stress may shorten the induction phase to unconsciousness, regardless of the gas used. The optimized CAS process proposes that this can be done either through a backloader or a tunnel system. The negative effects of exposure to high carbon dioxide in the stunning phase may be reduced by enhancing the environment in the stunner. In the backloader system, the climate conditions of a traditional pit system are optimized to achieve better control over carbon dioxide concentrations through the integration of additional sensors capable of accurately measuring both carbon dioxide and oxygen levels. In the tunnel system, a tunnel is used for the stunning process instead of a traditional pit system, facilitating the seamless transfer of pigs to the stunner and accurately managing the climate within the tunnel to ensure that gas concentrations are consistently maintained at optimal levels. The optimized CAS process focuses on improving carbon dioxide stunning while maintaining carbon dioxide as the stunning gas. The pre-stun handling, as well as the enhancement of the gas environment, can potentially also be applied with argon to move away from carbon dioxide stunning. The argon retrofit system is an alternative that uses argon instead of carbon dioxide and can be used following conversion of an existing dip lift or paternoster high carbon dioxide stunning system. As such, this system was successfully tested in a lower throughput commercial dip lift setting. The control unit for the stunner must be adjusted for the use of argon and is controlled based on residual oxygen content. The rate of insufficient stuns in commercial conditions is expected to be very low. At a dwell time of 250 seconds, no animals had to be re-stunned during the tests. Additionally, technical tests in a commercial paternoster system indicate that the argon retrofit system can be used to stun pigs in such a high throughput system with relative ease and low installation costs. However, given the exposure duration that is needed for proper stun with argon, the throughput per stunner was reduced. Additionally, argon is more expensive than carbon dioxide, so a high degree of argon reuse is advised. Importantly, the use of argon improved animal welfare by reducing the pre-handling stress, as pigs are less reluctant to enter the stunner, as well as reducing the aversion during the induction phase. Stunning with argon had no or limited effects on meat quality. The helium system is an alternative that uses helium instead of carbon dioxide, which was installed and tested in a municipal slaughterhouse. Because helium is much lighter than air, existing commercial stunning systems using carbon dioxide or argon cannot be converted to helium. The helium system consists of a tower in which the gondola with pigs moves up and lifts the animals to the top of the tower where the helium atmosphere is at its maximum concentration level, instead of going down in a pit. The tower is initially filled with helium before stunning and refilled during stunning to achieve a required residual level of oxygen. It has a recovery system which consists of double walls to recycle the helium and thus reduce the consumption. During the test, the rate of restuns was 1%, so an increase of exposure duration should be considered. The biggest investment when converting from carbon dioxide to helium is the reorganization of the stunner itself, which must be changed completely from a pit to a tower, but feasible when a new slaughterhouse is built. In addition, the price of helium can be much higher compared to argon and carbon dioxide, so the recovery system is essential. The induction phase for helium is significantly longer than for carbon dioxide, thus the maximum slaughter speed per hour is significantly reduced, but this could be counteracted by different approaches. The most important advantage of this alternative is that the use of helium significantly improved animal welfare, as no aversive behavioral responses were seen during induction. Stunning with helium had limited effect on meat quality. However, more blood spots and higher drip loss was seen compared to high carbon dioxide. Electrical stunning is an alternative to controlled atmosphere stunning systems and has the advantage that it stuns the animal immediately. The main drawback of electrical stunning is that animal welfare can be impaired during the pre-stunning phase, as pigs have to be lined up in a single row. Therefore, the improved electrical stunning system focuses on pre-stunning handling, design of raceways, and entrance of pigs into the stunner. To achieve this, different improvements were applied to allow the pigs to walk at a natural pace, increasing free forward movement and thus reducing handling stress. Firstly, the animals are guided from lairage to the raceway always in small groups, in a modified curved and wide raceway. Secondly, pigs are allowed to choose between two raceways leading to two stunners. This reduces handling stress at one of the most critical points in the raceway compared to conventional electrical stunning systems. Finally, more stunners were installed to reduce the number of animals per stunner and hour, which also allows for increased exposure time of the electrodes and facilitates a more effective stun, which results in less restuns. All these improvements may limit the use of electrical prods. To convert to the improved electrical stunning system, multiple stunners should be installed, which requires sufficient space. In addition, the layout of the raceway may need adjustments. The use of improved pre-stunning methods poses a significant improvement to animal welfare compared to conventional electrical stunning, due to lowering the pre-stunning stress of the animals. The discomfort from the stun is limited compared to gas stunning, since the electrical current results in immediate unconsciousness. Despite this, incorrect stunning occurs more often than in carbon dioxide stunning and needs to be remedied with an adequate backup method. Additionally, electrical stunning results in a larger number of carcasses with blood spots compared to carbon dioxide stunning. There are alternatives to conventional high carbon dioxide stunning which will improve animal welfare during the slaughter process. The optimized CAS process aims to improve the current high carbon dioxide systems. Its backloader idea is relatively easy to apply, while the tunnel system is likely only feasible when a new slaughterhouse is built. However, neither of the systems can eliminate the aversive effects of carbon dioxide. If other gases than carbon dioxide should be used, the argon retrofit system is considered a feasible alternative in the short term for slaughterhouses currently using carbon dioxide. Another option would be helium as stunning gas, but it cannot be used in an existing dip lift or paternoster system, as helium is lighter than air. Both argon and helium are shown to improve animal welfare during the stunning phase. Finally, the improved electrical stunning will require building modifications, but is considered to provide a feasible improvement to animal welfare before and during stunning for slaughterhouses with electrical stunning.